Okay. Hello, everyone, and thank you for joining the third meeting in our AI engineering workshop. And today we're going to talk about model evaluation. And so I have prepared a presentation about 20 minutes to summarize the main points and key takeaways from this chapter. And feel free to raise your hands and stop me for any questions along the way. And after that, we'll have some time for discussions. So you can also put the questions in the comments as well if you prefer to have a more in-depth discussion with the group later. Let me share my screen. Okay. I'll not share. Can everyone see my screen?
Yeah. Yes.
Okay. Thank you. So this chapter is around evaluation methodology. So what is evaluation and why it is so challenging to do model evaluation? So the main reason is from the last chapter is mainly because the answer from the foundation models are usually open-ended and probabilistic. So if we compare that to the traditional supervised machine learning, where for the structured data, we can easily define metrics and get the evaluation to see whether the model is performing good or not, and if there are some issues such as data drift, and we can detect that from the matrix and retrain the model, etc. But for the AI, is that we do not get 100% sure of whether the result is accurate, and it's also still a open and research question in terms of how to do that accurately. So there are some reasons why it is so challenging. The first is being time consuming for sophisticated tasks. Let's say you will ask the AI to summarize a book or documentation for you, and you want to know whether the summary is good or not. But in order to evaluate that, you first, or the evaluator also needs to read through that chapter. So that task itself is very time consuming to see whether the summary actually contains the right information. And the second one is you also need to do the fact check, reason, and even incorporate domain expertise to evaluate the model response. So still the example of document summary. Let's say if it's a medical or law document, and you will need some domain expertise to better understand whether the summary is good or not. And the next reason is impossible to create a comprehensive list of correct outputs to compare against. Yeah, because say in the classification model, we usually just have some defined target values. But here, basically, it's very difficult to know all the possible outcomes from the model, even though sometimes we can define, put into the prompt, say the output should be in this certain character or not, but still there's no guarantee that the model response only have these listed outputs. Yeah, another reason is the black box model details. So this means that usually if the models we use are proprietary, like say from OpenAI or Gemini, so we don't really know a lot of the model architecture, training data, or other information inside this model to evaluate whether the response is good or not. So then this leads to the question, how do we do that? So the most straightforward way is human evaluation. So essentially, just like we usually have human to do the labeling of the data, we can also do manually evaluate the results as the first step or the easiest way to get started. So this is very essential for certain domains, like where the human input is very important for some regulation purposes. And the other reason is that this probably is more reliable and controllable than using AI to do the evaluation. Because this way, the human can only give the expected evaluation. But however, in production especially, human evaluation is much slower because human cannot work 24/7, and also it is more costly because just as using human to do other tasks, and also it's not very scalable because with more API calls, we also need to have more responses to evaluate. When the amount or the volume of API call increase, we also need more humans to do evaluation. So it's not very scalable. And also it will be introduce some bias and preferences of the individual human evaluators. So that's why in this chapter, the focus is around a lot on the using AI as a judge to do the evaluation. And before we get into different approaches, it's also valuable to talk about some common metrics for evaluating language model as some basic foundation knowledge. So I probably many of you already know this before, so I'll just cover this very quickly. So three main metrics. So one is entropy. So essentially it's measuring how much information a token carries. If its entropy is higher, it means the response is less predictable. And the notation we use here, like the HP is the entropy of training data, and Q is the length distribution of the training data by the model. So ideally, we want the distribution of the real data as close as to the length distribution. That means we basically the model learns all the information from the training data, but it's not possible. So that's why we have another metric called cost entropy. And essentially it measures how difficult to predict what comes next in the data set. And we use a chaos divergence as defined here to measure how the true and length data distribution are different. So essentially, if they are very close, we can perfectly predict what comes next in the data set. But if not, if the model is not really learning a lot from the training data, and there's a lot of the uncertainty and difficult to know, to let the model to know like what comes to the next. So the answer will be less predictable. Combining these and the right now in the industry, the more common used metric is perplexity. So essentially, it is the average number of choices it has when predicting the next token. So essentially, you see the 2 to the power of the cost entropy for the definition of perplexity. So essentially, also if we have lower cost entropy, lower capacity, better model performance. By better model performance, it means that we can get more predictable responses. Yeah, next we are going to talk about 3 common approaches we use to do the model evaluation using more automated manner. So the first one is measure the response by functional correctness. So I think this one is easiest to understand. Essentially, we measure by whether it performs intended functionality or not. So essentially, if let's say the performance evaluation at work by a worker, and we can just see whether this worker finished all their tasks or not by looking at the output. And this is the best fit for coding tasks because let's say if you are using Copilot or Cursor or this code generation, and we can just copy this code and run it against the against some unit test to see if there are any bug or other issues. And this way we can know whether the code generated by the AI does perform the task or not. Another example in the book is gaming bots. So essentially, if in the virtual environment, if we have this sort of AI agent or bot, and we can also see whether it is getting a good score against other players or not. Or say if an agent to book a flight ticket, we can also see whether it indeed gets a good deal for us and finish all the booking. However, the issue of this approach is that a lot of the tasks we cannot measure the output easily. Let's say the document summary example. We can always get some summary, but we still don't know whether the summary is good or not because sometimes very subjective. So the second approach for certain tasks. So these are more like for different use cases, not like different approaches for the same use case. So for some use cases, we can also use similarity scores. So this is to measure against the references data and ground truths if we have any. So I think this is best for the use cases when the design output is pretty just maybe a certain name or short phrases. Like what is if we ask the model some common questions, like who won the Nobel Prize in economics, etc. And these short answers we can use some similarity scores against the ground truths because these are usually have the right answer we can compare against. So there are 4 common ways to measure that. The first one is also using evaluator, even manually or using AI, to ask whether this output is indeed same or similar to the reference. And second is to see if we exactly match or not. Like say we ask the model which year did George Washington was born. So this question have the exact match answer. The next one is a lexical similarity. So this is essentially to count how many common tokens using algorithms such as fuzzy matching to see how many edit distance needed to convert one word to another. Another one is n-gram to see the overlapping of token sequences. So these are the traditional methods or metrics in the computational linguistics to actually measure how 2 sentences are similar or not. But you can easily tell, like sometimes the tokens are similar, but have totally different meanings. So that's why we have a more common method is semantic similarity to measure whether it actually has the same meaning or not. Because in the end, we care more about whether the meaning is closer to our desired output or not. And to do that, there's a very common technique called embedding. So essentially to convert the token sentences or paragraphs into the high dimensional vectors in a vector space. And then in this way, for the 2 sentences, we can calculate the concise similarity between that 2 vectors to see whether it is close or not. So that technique is already very widely used in lots of the domains. And the issue about this approach is that it's very costly as well. As if to create the embedding, that is another layer of the task. And also sometimes we don't have the references data to compare against. So that's why right now the most common approach is AI as a judge. So the benefit of that is the 5 points here somehow it mitigate the cons of the other two approaches. So the first one is we can use AI as a judge to measure any criteria. So some common ones are correctness, repetitiveness, and hallucination. So we can just define any of the criteria we want in a prompt and then using AI as a judge to measure on these criteria. So before I go next step, so essentially AI as a judge, to think the easiest way is after the model gives you a response, basically we have another prompt to ask AI to evaluate for that answer and the question whether and give a score or asking whether it is factually correct or not. So this way we can have so in this way we have another model response, but this one is to evaluate the previous model response to see if that one is good or not. So as you can see, it can be easily automated in the system, and usually, as some research indicate, it has the good performance or on par with the human evaluators for some tasks. And also, there's no need of the references data if the reference data are just some common facts, and then the AI should already know that in the training data set. And also the scores are dependent on the judge. So this is both a pro and con because we don't need to deploy multiple humans, which could be very difficult to combine the answer. But here we are just using one model as a judge. But also the con is that the model can produce inconsistent results. And if the model version gets updated and we also iterate the prompt version, language itself, then the benchmark will be changed. So essentially, we really don't have any historical data to compare against because the underlying criteria also get changed. So the recommended approach by the book is, or maybe the future research direction is in the book, in the supervised, specialized AI judges that can predict which response user preference or not. So this means we have a smaller, more specialized AI judge to do the evaluation instead of calling the generic foundation model. Yeah. Another con here is the more cost and latency because you are calling more APIs, and in terms of latency, so usually you don't need to do that before showing the result to the final users if it's not necessary. But if it's necessary, then there will be some latency into the system as well. But the more common approach is that you get a response from the model and put into the database, and then the UI get the data from the database, and then maybe in parallel or asynchronously, you can also call the evaluation prompt and store the evaluation scores or results into the database. So this way, you decrease the latency because the more APIs you use or in the streamlined pipeline, you will be later to let the user see the results. Now, another thing is about the model and AI bias as well, because the AI could also sometimes have some preferences, like certain type. The book mentions some research in terms of the model. We usually prefer the response they generated instead of the response generated by other models, which is quite interesting. And the other one is the first position. So say if there's different options to evaluate between the outputs, the model usually would prefer the one appear the first, while humans would usually prefer the one showing up at the end. So that is also a bias. Lengthy means that if we are comparing two task summaries, and the AI will usually the longer one is better than the shorter one. So these are all things like as researchers and AI developers, we need to consider, evaluate, and do a lot of testing on before we deploy that into the production system. There's also a small section here in the book called model evaluation and comparison. So this is more around how to know which model is the best for your use cases. Because there's so many models, and on the news, when a new model release, they all claim to be the best, right? So it's a lot of noise. And so there's some technique called point-wise and comparative evaluation, essentially to compare against these different models. And there are also a public model leaderboard, which I'm going to show you example here. So the one called large model arena.ai. I think was previously developed by some researcher at UC Berkeley. And this one got pretty viral and commonly references in lots of the news and research as well. So essentially, this is a UI the researcher at UC Berkeley developed to help you understand how the different models compare against with each other. So here you can put this on prompt, and I think here it will basically show you the response of two models, but not telling you what are the underlying models to reduce some potential bias. And then before showing you the answer, it actually will let you pick which one seems to be the better. So this way you can have a more to help you better make the decision without knowing which model that it is using. Another tab here is side by side. Essentially, you can choose different models from the list and run a prompt, and you can compare the responses from different models. So leaderboard, Hugging Face, a similar one here as well. So this one also, they have their own score, arena score, and some other information, votes as well. So there's a lot of information here. Arena Explorer. This one is also pretty interesting because it actually shows you how people are using the chatbot arena. So basically use AI, what kind of prompts. So you can see most of the people are doing programming, math, creative writing. Yeah, these like programming and the math. These are the most common prompts people run here. And probably similarly using the other AI tools as well. So essentially, the reason why this session is covered, because I also see from my experience is that when you want to get started with a project, you have so many options, and to reduce the capacity of the whole project, you just maybe pick one of the models. But then, so you need to not only consider the model quality, how the response is for your task, but also the cost as well as other data privacy considerations as well. And once you get hooked with using this model, it will usually be more difficult to switch to other models, because in this way you might see some unexpected changes in terms of the response quality. But I think another common approach people are using here is basically using a hybrid of different models, or maybe a model uh, abstract layer of the model, more like serving as a router, so that when you call the API of that router, it will basically route the response to different models and do some aggregation. So that's also one approach I see some people or teams are doing as well. But if you just want to know which model you whether using Gemini or OpenAI to get started with the project, so this public model leaderboard will be a useful information to check out. But still, the most important thing is to do some testing with your real data to see how it is compared against each other. Yeah, so here are the main takeaways from this chapter. So important to have model evaluation and define the criteria and metrics, doing the evaluation of which model to use, AI as a judge, which seems to be the most common used approach. And ideally, if you have the resources and time, you also want to deploy some human feedback to reinforce the model learning as well. And lastly, this chapter is mostly on the methodology. And the next chapter in this book is still on evaluation, but that will be, the focus will be the evaluation pipeline in terms of how you can incorporate evaluation as part of your whole AI system. Yeah, so keep turned on for the next chapter. So that's all the presentation. Let me stop sharing. Yeah, I think I talked for a while. So does anyone have any questions? Or some things you find really interesting and want to talk more about? Go ahead, Nabra.
Yeah, I wanted to just I guess thought like AI as a judge, it's also not that interpretable, right? Like how do you trust the output? And I know that so previously I've used AI as a judge, and I guess the one way is to like ask them to provide their reasoning for giving the score.
Mm-hmm.
But it's also like tedious to manually review the reasoning to make sure that it makes sense.
Yeah, definitely. Definitely. That's also the major con of using AI as a judge. For the reasoning, yeah, the only hope I think is that when the model gets more advanced in the future, like the OR model, which now has more reasoning capability, which in the future the model can provide the reasoning as a part of the response. So hopefully that will be something possible in the future. And in terms of the other one, so the book also covers a little bit. So there are also a lot of the open source framework or even some startups doing the evaluation as well. So these tools essentially help you to do the evaluation in a more structured format. So one example I did some research into while reading this chapter is a company called Galileo. So essentially they are doing a lot of the model evaluation. So you can have some UI and metrics all logged into the system. And then there are also a lot of the controls and gateways they implement so that you can just easily define what you need and do the evaluation from their toolbox. Yeah. But I think that's all I know for the moment. Does anyone have other something to add for this question? But yeah, definitely, as Chip mentioned in this book as well, is that evaluation is a very kind of like undervalued and topic that deserves more attention and research and also development. So, so definitely, I think there will be more and more tools, frameworks, or better techniques or whatever coming up in the next few months in terms of how to let people do the evaluation better, because the trend now is more on shifting from just a demo to using AI into the production. And then in the production environment, people will care about monitoring and evaluation more than just the demo. So definitely that's more and more people are aware of the importance of evaluation, and then yeah, I think there will be more tools coming out on this field. Does that answer your question, Loretta?
Yes, it does. Thank you, Lee. Yeah, and I agree that there's like lack of good kind of approaches to do evaluation more robustly and like more, I guess, like in a more automated way, but still being trustworthy.
Mm-hmm. Yeah, definitely.
I guess
Yeah.
another
Go ahead. Go ahead.
I guess another question I had was that when you say specialized judges, like did the book or did the or like people on the call, do the thing does it mean like more fine-tuned models that kind of work only for evaluating a certain criteria, or how do you specialize the judge?
Yeah. Mm-hmm. So different ways. So one is fine-tuned model, but I think the previous chapter also talk about, yeah, you also need a lot of cost and resources to do a fine-tuned model, right? So, but if you have the fine-tuned model to have more domain knowledge, that definitely would be ideal. Another thing is that even for some domains, let's say in medicine or law, as examples, there are some like models as a service just for these fields, some meta AI or something. So these ones are something that you have more specialized knowledge in this field compared with OpenAI.
Mm-hmm.
Yeah, I think these are like special, but there's no like defined definition for what is special that it is about. But if you think about this way, in the past, OpenAI also has a custom GPT where you can provide some documents so that it can give you more curated answer given the provided references. So I think hopefully maybe in the future everyone can have this specialized AI as well. But I think go ahead. Yeah, go ahead.
Yes. Yeah, I think you also can use RAG. Like if you don't want to fine tune your model or you don't want to pre-train your model, you can also use RAG just to it's like you let your model to read some specific domain knowledge that you have, and then you can use that model based on RAG, and it can serve as a specialized AI tool. Yes, and you don't have to fine tune.
Mm-hmm. Yeah, definitely.
How would you use a RAG model to do evaluation though?
If you're having some models, you can use it for different purposes. And if you want to, let's say, if you have a specific document and then you want your model to learn that document, you can basically use RAG to let your model learn the document and let it finish the task. And the task can be evaluation. That's my understanding.
Mhm. Yeah. So essentially, the recommendation in this book is that you don't need to necessarily use the same model to get a response and do the evaluation. And for the evaluation piece, you can have something else, maybe a smaller, cheaper model, or even RAG as more like your in-house solution instead of calling the model like the API. So definitely, I think yeah, unit RAG could be an option. Especially if you think about RAG as it's the references data, as we talk about here for the calculating the similarity. Yep, does that answer your question, Namrata?
So I guess just to clarify what I understood, maybe the document that we're feeding into RAG has like the evaluation criteria, and then the model uses that to do the evaluation. Is that how you would use RAG for evaluating other models' outputs?
So maybe I can provide the example from my understanding here. Right? So if we want to summarize the document, and then we first call the OpenAI API and give that PDF, okay, to summarize this document, and we get 100 words summarization. But in the prompt, we ask the AI that to highlight and keep some of the information, for example, the name and location or the other important events. And then to evaluate that, we certainly just cannot coin the AI to see what big. But in that case, we are going to pass the PDF again. So then for the evaluation piece, maybe we can have the RAG, which has all the documentation we have in our database. Essentially, in the evaluation, it will just do information retrieval to see whether this the names and other important information we want to keep in the summary actually exists in that document.
I see.
Yeah.
Okay. Yeah, I understand now.
Yeah. Yeah, so basically RAG is more useful for the cases when we have these documents and references data. Because in these cases, we really need to have accurate response, not like hallucination. Yeah, maybe we can talk something more interesting. So do you have like any use case or non-use cases or see any applications powered by AI but give you very funny or totally wrong responses? So in other words, lots of the companies right now are doing having the AI features, but definitely not all of them are doing the evaluation that great. So do you see any of the AI responses on these apps or software which give a totally wrong or not useful information? I think the one maybe the most famous case is the Google search. I think almost half a year ago, when doing some search, they will give you some totally wrong AI generated response. I see some people talking about like when they search their name or something, they were basically referring to another person, which are totally unrelated, or some just factually wrong response. I think that's yeah. Go ahead.
Sorry, yeah, I can also share one very funny application, which is fortune telling. Like you give this AI your birthday, and the AI will list your birth chart and predict what will happen in your whole life. And sometimes you can clearly tell that the birth chart isn't actually correct from the beginning. But if the AI is working with somebody that's totally not familiar with anything about birth chart or fortune telling, maybe they can be persuaded that they are the true thing. But if you take a closer look, actually the AI is doing a really bad job at fortune telling or birth chart. So that's a very funny case that I've seen recently.
Yeah, definitely.
Oh, another thing I could share is about, I don't know if you have the chance to use the Apple Intelligence on your iPhones, because I know like a few months ago, they've been rolling out the summary of notifications, right? So when you have too many messages and notifications, it will summarize and give you like a sentence for you to overview it. But then I remember it was there was a CNN news about someone who like a celebrity who was recovered and was released from the hospital. And Apple summarized it in the opposite way, saying that the celebrity has died in the hospital. So that was a bit chaotic. And I remember Apple like put a pause on summarizing all those notifications from like news outlets. So I think another interesting case here.
Yeah. Thank you for sharing, Ray. Yeah, in this case, it's kind of really difficult to do the evaluation because it's deployed on every device and a lot of the volume. So I remember another case covered by this book at the beginning is also character AI. Not sure if everyone is familiar with that startup. So in character AI, let's say you can have an AI that's serving a certain role. There was a news where a teenager basically kind of got obsessed with that AI girlfriend or something, and then somehow that AI asked that person to die, and that person actually committed the suicide. So that's also the time when the AI response is definitely goes out of the boundary and gives some dangerous recommendations to the user, which lead to very harmful results. Yep. Perfect. Anyone have other questions?
Yeah, just wanted to say thank you so much for this presentation. It really is super helpful, and thank you so much for taking your time organizing those events. Appreciate it.
Yeah, you're welcome. Thanks so much for joining. And yeah, we'll have this every week. So this chapter 3, so it'll be 7 more weeks. And I think the first few chapters are still warming up and first, but the next few chapters, yeah, hopefully everyone will get a lot of useful information from them. So for example, in the future weeks, we have the RAG agent, prompt engineering, also the system design related topics. So yeah, looking forward to that. And thanks so much for everyone to join as well. And yeah, if you have any follow-up questions or want to network with other AI practitioners, so Discord channel is a great opportunity to do that as well. Okay, let me
Thank you.
stop sharing. Yeah, next chapter, we will have another presenter.